Hey there, welcome back to another edition of Mr. Chestnut's Notes. In this video, I'm going to talk to you about solving a system of equations via elimination. So, in the key points, I say that if necessary, you're going to multiply both equations to cancel out a variable. That's the first and foremost thing that you're doing. It's called elimination because you are eliminating a variable. So, when you're looking at these equations, you're looking to combine the equations, and by doing so, you will eliminate one of the variables and solve for the non-eliminated variable. So it's similar to substitution in that sense. And then you'll plug it back in and get the other variable. So that's basically what we're going to do. I'll start with number one. Why not? So here, look, if I add these two equations together, I eliminate the x's. The x's eliminate right away. I didn't have to do any sort of manipulation to either equation, and we will on these other examples. But I'm going to add negative 3y plus 2y, and that'll give me negative 1y equals, and 2 plus negative 3 is negative 1. So if negative y equals negative 1, positive y equals positive 1. Okay? So what you're going to want to do is go back and plug it into one of the original equations. It doesn't matter which one. This top one looks maybe easier to do with. So x minus 3 times 1 equals 2. So x minus 3 equals 2. So if I add 3, I get 5. X equals 5. All right. That's the final answer. 5, comma 1. Write it as an ordered pair. And so you can always check your work by plugging it in, and it should work for both equations. So I'll just plug it into that bottom equation since it didn't seem like we did anything with it, but when we did the elimination process, we did use that second equation. But let's see here. So it says negative x, so I'm going to write negative 5 plus 2y, so 2 times 1. Does that equal negative 3? Does negative 5 plus 2 equal negative 3? Yes, it does. So we were just checking to see if it equals negative 3. It does. Yeah, that's it. I'm just repeating myself now. That's basically it. Let's move on to the next example. Here, I'm going to add the two equations. Well, first I'm going to check to see what variable I can eliminate, if I can. And I see a negative y and a positive y, so I can eliminate those right off the bat. So that's going to be 7x equals 5 plus 9 is 14. So divide by 7 and you get 2. So now I'm just going to take 2 and plug it in for x. It doesn't matter which equation, so I'll use the bottom one. So 3 times 2 plus y equals 9. Alright, so 3 times 2 is 6. 6 plus y equals 9. So y's got to equal 3 because 6 plus 3 is 9. Or subtract 6 from both sides. And 9 minus 6 is 3. So there we go. We got 2 comma 3. And again, you could plug it back into your equations to check your work. But to save time, I'm going to skip that process like I did on number 1 here. This was just a check, so I should have written that down. Check. All right. Okay. Number 3. X plus y equals 7. 5x plus 2y equals 8. If I were to add these two equations, I wouldn't write anything down if you're following along with a copy of this paper, because I'm about to erase it all. If I added these two equations together, I would get 6x plus 3y equals 15. None of the variables are eliminated. So the first step isn't always just start by adding the two equations together. No, what you're going to want to do is you're going to have to multiply one of the equations, or both, by some number to get it to become the opposite value of something you can eliminate. So it sounds awfully confusing, but pick a variable you want to eliminate. I want to eliminate the x's. So I'm going to multiply this top equation by -5. Why? Because this has a 5 by it. So I know -5 plus 5 equals 0. So what I'm going to do is I am going to distribute this -5 to everything, not just the left side of the equal sign, the right side too. You can multiply any number to an equation as long as you do it to both sides. It's just like the rules of algebra. You're trying to balance the scales here. So if I multiplied something times 5 on this side, I need to multiply it times 5 on that side. So yeah, so don't forget to multiply 5 times 7. So I'm going to rewrite the equation right here. -5x minus 5y equals -35. Now I can add these two equations together. That eliminates. Now I have -3y equals -35 plus 8 is, what is that, -27? And so now I can just divide by -3 and y equals 9. All right? So take the 9, plug it into an equation. I'm just going to plug it into this one because it's easier to deal with. X plus y equals 7, so x plus 9 equals 7. Subtract 9 from both sides, and you see that x is going to equal -2. So my final answer is -2, 9. All right. So if I lost you there, hopefully the next example will help. Because the first two examples were really easy when compared to number 3, at least. Because they had a variable that could eliminate right off the bat. You need to have the same number of x's or y's, just they need to be opposite signs so you can add the two equations together. So looking at this, nothing's ready to eliminate. Just to show you that it really doesn't matter which variable you eliminate, I'm going to eliminate the y's on this one. If I multiply this by 3, what's that going to get me? That's going to get me 15x plus 6y equals, and 3 times 19, what is that? That's 57. Yeah, so distribute it to everything. What do I have here? I have a 6y here and a -6y there. See, so that's how I knew to multiply this second equation by 3. If I were to eliminate the x's, I'd have to do more work. I'd have to multiply the top by like 5 and the bottom one by like -7 because they both go into 35. So it's actually less work to eliminate these y's. So I'm going to rewrite the other equation before I do anything else. 7x minus 6y equals 9. And now I'm going to add these two equations together. So that cancels. That gets me 22x, and 57 plus 9 is 66. So divide by 22, you get x equals 3. All right, plug it in to any equation you want. I'll just plug it into the top one for x. And so I got 7 times 3 minus 6 times y equals 9. 7 times 3 makes 21. So 21 minus 6y equals 9. So now I know I can subtract that 21 to the other side, because it's positive, so I'll make it negative. And so I have negative 6y equals 9 minus 21 is negative 12. And divide by negative 6 to both sides. And you get y equals 2. So there I have my answers for my x's and my y's. So my final answer is 3, 2. There we go. Okay, so put a few problems on the second page here. And the first two start off like the first two here, where once you add them together, one of the variables immediately eliminates. But then the next two you need to do some work. Looking at number 4, you're going to need to make sure everything is on the same side and everything's in the same order when you add it together, or else then it gets like way hairy if you don't do that. So I'd like for you to pause it, work these out on your own, and because I'm gonna do the same thing, so it'll jump cut to the answers. All right, bye.
Okay, so I went ahead and solved each one. You can see at the bottom I checked my answers, so I got 3, 4 for this answer. Moving on to the next one, I got negative 2, 4, and again I did the check step for all of them just to make sure I was right. And notice how I plugged it into both equations to check it, because it should work for both equations. It's rare, but sometimes you plug it in and it works for one but not the other. That's how you know you made a mistake. Alright, so this one was a little tricky in that this bottom equation, see how the top one, x plus 2y equals 7, there was an x, then a y, then equals a number. The other one was not in that form, so I added 5y to the other side. So then I could write x plus 5y equals 13. I just put the equals 13 on the other side instead of writing 13 equals x plus 5y. And so looking at that, I had a positive x up here and a positive x down there. So I needed one to be a negative x. So that's why I multiplied this entire equation by negative 1. And then from there, I canceled my x's, I solved for my y, and then I just plugged my y back in, and I got 3 for x. And then I checked my work down there. Okay? This one, again, they were not in the form where they're both able to line up. So I minus this 10x to the other side, and then I minus this 5y to the other side. And then I just rewrote them. I wrote the negative 10x first. See, negative 10x minus 3y. And then this one was good, negative 10x minus 5y. And then it equaled negative 11, and it equaled negative 5. So I was looking at these, and I saw I had 2 negative 10x's, so I needed one to be positive. So it doesn't matter which equation you manipulate. So I just multiplied this top one by negative 1, and so that flipped all the signs. Positive 11, now positive 10, positive 3y. And now I was able to add the two equations together. Excuse me, got the hiccups a little bit. I don't know if you could hear that or not. And so I got y equals negative 3, I plugged it in, I got x equals 2, and then I checked my work over here on the side, and it all worked out. Okay, so that wraps it up for the elimination video. These take practice, just be patient. But just to recap, it doesn't matter which one you manipulate as long as you have one variable that will cancel out when you add the two equations together. Then you're fine. Then you're off to a good start. Alright, so I'll end the video on that note. I hope this helped, and take care everyone. Bye.